Okay, what we're going to look at now is something called the hard landing indication system. And what this system does, it takes the guesswork out of if we suspect there's been a hard landing. People tend to err on the side of caution, and as a result, it's no bad thing, I suppose, but as a result, the inspections that are called up tend to be more detailed than they would otherwise need to be. What this system tries to do is take the guesswork out of the equation and quantify, was it a hard landing, and B, the severity of the hard landing, and then in a kind of binary way steer you into what checks that need to be done. And obviously on the other side of the coin, it means that checks will be called up where perhaps otherwise they would have been missed if people are perhaps erring on not on the side of caution but going the other way, being too over optimistic. So this system has a hard landing indication control unit as the core of its system, which has a multiprocessor and a data processing module and an aircraft interface connector. The multi-purpose processor collects discrete ARINC 429 and analog data and forwards that data to the DPM, the data processing module. The MPP, the multi-purpose processor, is used for the system built-in test. So the data processor module computes a delta G for each landing and records the delta G and flight data in a flash memory. The DPM also transmits the delta G and error data to the high landing indication system display unit, which is on the cockpit, and we'll take a look at that in a minute. The aircraft interface connector causes system fault and hard landing outputs. And the control unit also has pin programming feature, which gives the aircraft model ident to the hard landing indication system. The hard landing indication system display unit in the cockpits on the side console is connected to the hard landing system control unit through a connector. And this display unit receives power and signal from the HLIS control unit. The display unit includes a field programmable gate array to read and validate the data from the DPM of the control unit. This gate array then sends the data to the display panel when the push button is pushed. So inside the control unit, there's a whole bunch of circuit cards, each getting flight data from different various aircraft systems. Each circuit board receives data from different types of inputs, be it analog, discrete, or data. The multi-purpose processor then aggregates all of that data received from all those cards into a single stream and sends it through the Ethernet connector to the DPM. The DPM then records that data and analyzes it and basically calculates if we've had a hard landing event. The data is stored in a non-volatile memory implemented as a 1 GB compact flash card, and data analysis is made to determine the phase of flight, i.e. normal landing, etc., and to compute the maximum delta G experienced at the landing. So what's all this delta G we keep banging on about? Well, basically what the system will do is record the peak G value from a landing event. It will then look at the lowest G value 0.35 seconds prior to that peak to find out the change in G forces. In other words, the difference in G between the lowest value 0.35 seconds before and compare it to the peak value. That's called delta G. The delta Gs are sent to display unit for display through an ARINC 429 link. An Ethernet link from the DPM is made available at the HLIS display, so we can monitor the system or status data monitoring, and also download the information. It looks like a telephone connector there. That's the Ethernet connector. The flight data includes all the data that is collected and recorded by the hard landing information system or indication system, but not moved to the HLIS display unit. On the display unit, we only display that delta G value. The G data refers to the body acceleration data processed and shown on the display unit. If there's a fault in the system, obviously we're going to get to know about it. So if there's a fault in the hard landing indication system, either the MPP or the DPPM will operate the fault light on the display unit. So once we've got that delta G reading from the indication system, it's very simple for the engineer now to make a simple decision as to what we need to do. So all we need to know is the aircraft weight at landing. We get the G value from the system, and then we just plot it on this graph, and that will tell us what we need to do. Do we need to take the landing gear off? Do we need to just do a normal inspection? Do we need to do an inspection but a little bit more further data analysis? It makes things nice and simple and black and white. And that's the hard landing indication system as fitted to the Challenger 605.